So we're going through the test. So the number one thing you're going to have to do on this test is be able to look at the question and figure out what they're asking, what steps to use. And that's actually more of a part than like getting the right answer. Because you have all the steps. It's just a matter of which ones you have to use for the problem. So let's look at the first question. The key with doing any of these is looking at what they give you and then try to figure out what they're asking you for, and then that'll start giving you your steps. So I would highly suggest, again, getting something like, or even printing out a bunch of bell curves, just so you have a blank one. Copying one now. All right, so in this problem, what did they give us? I know you can't see me writing. I'll switch over after we get the information out of it, because this is bigger than what I have on my screen. So what did they give us?
A mean of 4.85 and a standard deviation of 0.05.
Seriously? Now you're going to glitch at me? Hold on. I'm going to kick me out of this. Okay. All right, so you got the mean of 481. It's got a standard deviation of 0.05. And we're looking at the top 10% and the top. We want the numbers that are going to separate the top 10% and the bottom 10%, right? Okay. So that's what they gave you. Okay. And we want to know those two numbers there. All right. So to find my x, we need to find the z, and then we can use that formula. So in essence, we're going to use this formula here. We're going to use that formula, except I need to find my x. So we're going to have to find the z first. So to find my z, I'm going to use the 0.10 as my percent on my z table. So find me 0.10. Now, this is a percent. So remember, we're looking inside because we're looking for the z on the outside. So we're looking for the 10% on the inside. Because that's 1%. So you move it two places. So 10% you move it two places is 0.10. So I think the closest I got is 1.28. Everybody find that? Yes. I got to make sure I bring some extra ones for the test because I didn't print them out.
Really confused how you were just like pulling numbers. And I was like, oh, he handed out a sheet.
Thank you. I left my folder at home. I apologize.
That's fine. So you're looking on the negative side because negative is going to be from 0 to 0.5, positive is from 0.5 to 1. So you're looking on the negative side. So we're looking for 0.10. So it's good easier for me to just literally walk over there and show you. So we're looking at here for 0.10. So 0, or is it bigger, smaller? That's the closest one. So then it's negative 1.2. That's the 0. All right, now.
C is negative, it's selected.
Correct. And to the right of the mean, it's going to be positive, and the bell curve is symmetric, right? So since I'm also looking for 10% on the positive side, I don't have to look this up again. I know this is going to be 1.28. Huh? Yes.
How did you find the 1 point like?
So in the middle, look for 0.10.
Okay.
So it's going to be on the negative side. And then find the one closest to 0.10.
The closest one I found so far is
It's 1.28. I know it's 1.28 because I just found it. So not 0.01, 0.10.
oh, okay.
So right there is and there's the closest one.
Gosh, okay, cool.
So there's the negative 1.28. Yeah, you have to make sure you know where your decimal points is, because if you're looking for 0.01, that's a lot different than 0.10. So, all right. So we've got now our Z. We now use my formula to go backwards one step to find my X. So Z equals the X minus the mean over the standard deviation. In this case, my Z is negative 1.28. I'm looking for X. My mean was 4.8. 4.8. And my standard deviation is 0.05. 0.05. And I'm also doing 1.28. Same things. So we have to multiply. Oh, that's good. She got 3 people to this house. At least it's somebody. So we've got negative 0.064 and 0.064.
Wait, can you back up a second?
Yep.
All right. So how did you get there to do?
I multiplied 0.05 on both sides, getting rid of the division.
All right. Cool.
And then we add the 4.81 over. So we get 4.874.
Sure, I don't know your first name.
Jackson.
Jackson. You took the negative 1.28 times it by the 0.0.
Oh yeah, I see that now. Thank you.
You're welcome.
Appreciate that.
And this side comes out to be 4.746. Equals 6. And that's the answer. The answer was they wanted to know between which two values gives you the top 10%, the bottom 10%, and they want it to the nearest hundredth in this case. Oh, it doesn't tell me if I get the answer right until after the end of the test. Darn it. That's fine. Okay, so it really comes back to what are they asking and the steps, because this problem here, the same steps that we just did for this, like 3 different problems look like this. All right, it just depends on what they gave you and what they're looking for. If they're looking for the X, these are the processes you're going through. If they're looking for the Z or the percentage, you have to go the other direction. You've got the X, you're going to find the Z, and then use that to find the percentage. So, which we'll do one of those two. So, yes.
So when you multiply negative 4.81 by 0.05.
No. because that's on top. So I'm going to add that to the other side afterwards. So I multiply this whole side by 0.05, which cancels out with that.
Okay.
And then I multiply this side by the 0.05.
Okay, so just the other side would be,
Yeah, and then this, in the next step, I'm adding the 4.81. Make this one big enough so you can actually read it.
so would X be 4.746?
Yeah.
Gotcha, okay, cool.
All right, let's look at the next one. Newspaper company classifies its customer by gender and location. The research department has gathered the following data from a random sample of 1,870 customers. What is the probability that a customer is not male or does not live in a dorm? All right, so this is that sum of probabilities, right? So the question you have to ask in this case, are they mutually exclusive or not? So can you be not male and live in a dorm? Or not live in a dorm, I should say. Yeah, so these are not mutually exclusive. So there is overlap between these two. And since there's overlap, that means we have to subtract out that overlap because otherwise we're going to be counting it twice. Okay. So
What if those mutually exclusive?
you could just add the percentages. So like if I was asking you, what's the probability of adding a heads and a king? You could just take those two percentages and add them. But in this situation, since they're not mutually exclusive, if you just added the two individuals, you're adding that centerpiece twice, and you don't want that. What I would do on this problem is I would look at the graph, the table, and use the table to get your answer. So let's look at the table that we have. So this way you're not looking at it and doing it twice. So it's not male. Not male would be what? Right. So all these. Those are all not male, right? Does not live in a dorm. Now, since it says or, we're ignoring the first one. Now, does not live in a dorm. That would be those, those, and those, right? Yes, Cameron. Let me finish this one. I'll go back. So the red is not male. So not male. And the green is not dorm. Okay. So we would add up everything. So notice how there's that overlap. So if I just added up all the not males and just added all the females up, I'd get one number. If I added all up the not dorm, I'd get that number. But all these ones here that are circled twice is that overlap that I would have added twice. So that's the piece you have to worry about when you're looking at it. But like I said, I would do something like this in circles. So this way you can see that overlap and not have to worry about it. Yes.
So they're asking for how many are not male and not in a dorm?
Not male or not in a dorm.
Okay.
The key word here is or, not and. Okay. Or means either one can be true. So it can be lives with parents in male, that's fine. That's not male or not in a dorm. That would be not in a dorm, obviously. So since it's the or, either one would work. So add up all the numbers I circled, basically. And then the bottom is going to be out of 1870. What would have been an easier way to do this than adding up all the numbers? Yeah, just take the one thing that's not circled. Remember, this is the only one that's not circled right there. So if I take that one away, remember the converse of it, take that one piece away, I would get all the rest of it. A little easier to do those one subtraction than 10 additions or 11 additions.
What do you do with that 120?
I subtracted it from 1870.
So we get the percent of that?
It actually said you can do it as a fraction or a decimal. So you could literally leave it as that fraction.
Well, what I understand is the question was asking, what is the probability that a customer is not male, is not living born?
Right.
Well, why do we circle like the male?
No, not male.
Oh, the black one?
No.
It says or. So if you notice, right. So the red is the not male. And then the green is the not dorm. Since it's or, you could be male and not in a dorm. That's fine because it's the or.
I was thinking like not male.
Right. And that's actually the big, that's the difference between not or and. If it's not male and not in a dorm, then I would just be looking at the females that are apartment parents, sorority, or other.
John goes up.
Right. Exactly. So that would be the and because I don't want dorm or male.
Do we have to simplify that fraction or?
Nope, you can leave the fraction.
Okay, cool.
So, all right, Cameron wants me to go back to question one real quick. There's question one, Cameron. As I, it's literally designed to confuse you. But there's a reason why, like, they do that. It's not to be mean. It's to make sure you actually are really understanding what's written and not just going through it quickly through the rote memorization of it. So, like, that's why, as much as I know those questions are annoying, that's why I like them because it really gets at it. Do you understand what you're doing? So, if you did what you did, that gives me information. It's like, okay, they didn't understand what the word or meant. They looked at it as just two separate things and did that. So that gives me information about what you know and what you don't know, which is important as a teacher. Not that I'm going to use it or anything else because we still have to move on in the class. But if it was a regular longer term class, that would give me, then I could reteach those types of things and stuff like that. So unfortunately, college doesn't give us that opportunity very much. We good, Cameron? Okay. All right. Next one. All right. What are they giving you in this problem? Okay. Okay. All right. Where are the 97 and the 107 going to be? On the right side of the graph, left side of the graph, or one on either side? Why? Correct. Okay. And that's important because that means my Z's are going to be what? Both positive, which gives you information. Okay. So that's what my graph would look like. I'm looking for that piece right in between there. To thank one of my high school students because they're the ones who found the graph ones. And then I looked and I knew that standard deviation ones. Those little sticky notes I talked about.
They're clutch.
You give a sticky note.
You get a sticky note.
She gets to be Oprah today.
Oh, thank
You're
you.
welcome.
I appreciate this. Lady.
All right. It's the bell curve. So you don't have to draw the curve out every time. You can just draw it and it sticks it into your paper. And yes, you can use them on the test and you can stick them right in your testing.
This is what?
Huh?
What is this?
It's the bell curve. It's that curve I just drew there. So you don't physically have to draw it out by yourself. You can do the lines and stuff on it. So, all right. So we've got that. So we're looking for percentages, right? So the only way to find percentages on here is to find my z-score. So I named my z-score. So remember, z-score is x minus the mean over the standard deviation. So in this case, I've got z equals 97 minus 80 over 30. And 107 minus 80 over 30. So you should get 0.57 and 0.90. Yes.
Actually, I think I know that's
When you type these in, make sure you do the subtraction first or put them in parentheses and then do the division by 30. Make sure the 30 is in the bottom because if you just type this straight in your calculator as 90 minus 80 divided by 30, it will do the order of operations correctly, which means it divides 80 by 30 and the subtraction from 97, which is not what you want. You should know when you get an answer. Like if you did it the other way, you'd get an answer like 94, and you know that doesn't make sense for a z-score. So then go back and look what you did. So like those are little things that you should recognize that doesn't make sense. Don't be like my high school students who goes, that's what the calculator said. Yeah, but garbage in, garbage out. All right, we've got our z-score, but we want what? We want the percent. So we've got to take the z-score, go to my table, find the percentages. So 0.57 is 0.71566. And 0.9 is 0.81594. And then what are we looking at for? So what are we going to do with those two numbers? Subtract, because we want between them. So the answer is 0.10028. Because we want what's between them. That's why the shading is important, because that will tell you what you're looking for. Okay.
That's the answer.
That's the answer.
Yeah. How important is it that we keep track of the graph?
Important as in that's what I'm going to look for on your test? Not. Important for you to actually make sure you get the right answer? I would say highly. Because this kind of dictates where you're looking. Like if you don't have the shading thing, you don't know what you're doing with those numbers. You might not recognize that, okay, they both, the z-scores should be positive if you don't look at which side of the graph they're on. So you might look at the wrong side of the table. Like those are the things that that graph is supposed to help you figure out. So no, the graph is not important for the answer. The graph is important for you to figure out what you need to do for the answer. Does that make sense? Okay. All right. Next question. This one I can just put here because this is the multi-step question. All right. So this one, we need to find out.
It's question 4.
Yes, but they might not be in the same order, so don't necessarily automatically go by that. All right, so this one we're looking at figuring out our expected value. We're looking at figuring out our yeah, our variance, our standard deviation, those steps. So, expected value. Yeah, and it asks, so this is what it looks like. See, it shows this and it says step 1, find expected value. And then when you hit that, step 2 is going to give you some more. On your test, it's going to have all 5 steps listed there. So it's just 5 things you're looking for. Now, here is a understanding of how I do my tests if you haven't already figured this out. I grade my tests. Every question is the exact same value. Every question is 10 points, right? There's 10 questions on the test. Each one's worth 10 points. Doesn't matter how many steps the question has. This step has 5 questions. This question is worth the exact same amount as every other question on the test. This one has 5 steps. So if for some reason you can't remember how to figure out how to do some of this stuff, don't spend your entire class period looking at this one question to figure out how to do it and run out of time and rush through the other questions. Okay? Go do the other questions and then come back to this one if you don't remember how to do some of these. Because I'll tell you that this is the longest question on the test. Okay, because you do have to calculate standard deviation, you do have to calculate variance. Those things do take a little longer to do. So out of all 10 questions, I would say this is probably the longest of the 10 questions. All right. Okay, so expected value. Expected value we have to do is we're going to multiply. So this is the equation for expected value. What it is you're going to multiply the x times the probability and add them up. So -4 times 0.2 is -0.8. -3 times 0.1 is -0.3. -2 times 0.3, -0.6. 1 times 0.2, -0.2. And then 0. And then add them up. So my expected value is -1.9. That is also known as your mean.
So what? That's what you need.
That is also your mean, yes.
So the mean is negative 1.9.
Yes. So your expected value and your mean are the same thing. All right. Questions with that? Okay. Next part, yeah, go ahead.
What, you multiply them all together?
Add them all together.
Okay.
That's what that little symbol right there means sum. That's the summation symbol.
What's the name for expected value?
All right. Next thing I asked you is your variance. This is why I said this problem is long. To find your variance, you have to subtract each of the x values from the mean, square it, and then multiply it by its probability. So we have -4 minus -1.9. -3 minus -1.9. -2 minus -1.9. What? Minus -1.9. And this is the part that's annoying, and I understand that, and there's nothing I can do about it. Yeah, it's so that's why I said if you're gonna like find the expected value, look at some of the questions. If you're gonna skip the standard deviation, the variance, like there's other things that you can figure out to get points. Like if you're gonna fail on a question, like these are the ones that I would expect you to struggle with. Summation,
Big symbol is bold as sum.
that summation. That's the sum of the values. Basically means after we do all this, we're going to add them all up. So step one is to do the subtraction. And this thing is actually going to be adding 1.9 because it's two negatives. Yes.
And this is all part of one question.
Yes, this is literally one question. That was your mean. That you found in the last question. Yes. Yep. So I've got 2.1. -1.1, -0.1. Then I got 0.9 and 1.9. Then square them all. So 4.41, 1.21.
Lots of positives over there.
Yes, because they're bigger than the mean, so you would expect them to be positive. The nice thing is when you square them, the positive goes away, or it doesn't really make a difference because positive times a positive is a positive, negative times a negative is a positive. Yes.
Is it the mean of X or the mean of the stuff below it?
That is the mean. That's where the 1.9 came from, expected value. So the mean is your expected value, which we figured out in the first problem, the first part of this, by doing the multiplication and adding them all up.
Okay, so I see.
Yeah. And then you take that mean away from all your X values. So those values there. Then you square all those answers. So we've now done that part right there, basically. So the next step, we have to multiply by the percentage. So we're going to multiply that by 0.2, that by 0.1. No, you can do it out any way you want. I don't care. I'm writing it out so you understand what I'm doing. Because if I didn't write it out, Everybody would be lost. Yes. Yes, then multiply it. So I got 0.882. Zero 0.121, 0.03, 0.162, 0.722. Huh? Now we're going to add them up. That's the number we're going to add up. Remember how you asked me a little while before how to actually find standard deviation? And I said you would never really ever have to do it. This is the only situation you're ever going to have to do it on a test. Because there's no easy way to put this attention to it. But this is in essence what you'd have to do always to find standard deviation. And it's a lot, especially if it's more than a couple numbers. Okay, so this question wanted to know your variance. That is your variance. Variance is the square of standard deviation. So to find standard deviation, I take that number and take the square root of it, which is literally the only other step I have to do for step 3. Yes, the last part was adding them all up.
How many decimals?
1, 2. I think the question's going to ask for 1.
It'll say how many.
Yeah. All right. Standard deviation. Yes, go ahead.
So we add all of them up.
Yep.
What do we do with those?
That's the variance.
Oh, yeah, okay.
Standard deviation is the square root of the variance. So it's the square root of 1.19. So, yes.
Was this the problem where you said the website?
I haven't found one that can do with the probability. Oh, wait, or did I? Hold on. I take that back. Wait a second. I know I found another website, but I don't remember if it was for this one or not. Oh, yeah, I did. So, yes. Thank you for reminding me. I totally forgot about that. Yes, there is a link on my website for this one. But now that I'm basically done with it, I might as well finish it. All right. And then standard deviation is that 1.38. And yes, there is a website for it, so you could use that. That's fine. Yeah, you can use any of the links on my website you can use. So there's 2 links. Actually, what I'll do is when I post this, I'll link the 2 things to the beginning of it.
The review test? Or the-
No, because you can type them in here. To do what I just did out by hand, this will do it for you. And you can use this on the test. Because as I said when I taught this lesson, you're never doing it out by hand. But I couldn't find it. I didn't find it, and then I found a website. So, because it's a pain in the butt and it's long, and nobody ever does this out by hand anymore. All right, the last, yeah, because you can use Desmos anyway. Most people are going to use the Desmos on their phone anyway, so that's fine. I'll be able to tell pretty much on what you're writing if you're cheating or not. So I need to see some work, like, so you're still going to have to figure out those answers and stuff like that, and figure out what you need to do and those type of things to get that answer. So that's fine. All right, the last part of this question asks, find the value of if x is greater than -1. So what is the probability that x is going to be greater than -1?
When you subtract that number by 1. Or do you find it? Or do you find this number like?
So look here. What's the probability that x is greater than 1? -1. The only number is 0.2. So the probability is x is greater than -1 is 0.2. Because that's the only one greater than that. Okay? Then you add them up. Add them up, yeah. So if it's a greater than, for example, if it said x is greater than -2, it'd be 0.4 because I would have added those two together. All right, moving along because we're getting close on time and that question was long. Luckily, not all the questions are going to be that long. Okay, that's another question like we already did, so I'm not doing that one. All right, there's 10 people in office with 3 different phone lines. If all the lines begin to ring at once, how many groups of 3 people can answer these lines?
If you skip question 5.
I did because it's literally the same as one of the other questions.
Okay.
So there was no point in me doing it. It's the same thing. It was another one of the. It was another one like question number 1, or not question number 1, like this one. It was another question like this one. Because those are important, so I put a couple of them.
Right. So in the code, we can expect multiple of the same kind of.
You could, yeah.
Okay.
So, because those are from that section. All right. I'm here. I literally just typed something in for crying out loud. All right. So there's 10 people in an office with 3 different phone lines. If all the lines begin to ring at once, how many groups of 3 people can answer these lines? So this is a permutation and combination problem. So this is that P or the C. The question that you have to ask is, does order matter? No, because it says they're all picked up at once, right? So then it doesn't make a difference who pick. It's like 3 people are going to pick them up. So how do we figure out? So we're just going to use the Desmos calculator. And I'm doing, let's switch over to this one. So I have 10 people. And since order doesn't matter, I'm using C and I'm choosing 3. So C and P is order matters. So use the NCR, 10 choose 3. And there's 120 different ways. There's 120 different groups of 3. Yes.
How did you write that out?
I literally typed it into the calculator. Honestly, the key question with this one is remembering which one to use. Is you're either using combinations or permutations. So that's really the biggest question in that one, is to really remember which one you need to use and to realize that you have to use that.
What did you put in the calculator again? Yeah. 10. And is this on decimals?
Yep. On yours, yeah, probability, and you'll see NCR. You have to type in the number first. So you're going to do 10, NCR, and then 3. And you should have got 120. I don't know if, I know you can flip it sideways, but I'm not sure if NCR is one of the options.
this would be able to like, I'm gonna do this on my phone, so.
Yeah, that's fine.
Could I like Google NCR calculator?
No, use Desmos. It's literally just use the Desmos scientific calculator.
How would you find this like on like mobile app? Is that?
Oh, hit functions
Okay. Oh, yeah.
and then scroll down.
Oh,
Keep going. Keep going. Keep going. Right. There it is. Right about it.
Oh, NCR, all right.
Huh? Desmos.com. Desmos. DESMOS. Yes.
You can also just get the app.
Yes, or you can get the app. App is great. There's two of them. There's graphing calculator and the scientific one. You really don't need the graphing one. The scientific one would be just as fine, but they both do it.
And for if it doesn't matter, would it be NPR?
Yes. So if order mattered, so like, say each person is a level. So like the manager has to answer the first phone, and then order would matter in that situation, and then you'd use P, and the number would be 11.
I remember it was like really long. That was a good. It was like
There's a binomial probability question that you have to use, that you have to do it multiple times.
yeah.
Yeah. Yeah, there's one of those on here. That's not this one. So the difference is so when you're looking at it, this one doesn't ask you probability. This one just asks you how many ways can they answer. If it's looking for probability, you're probably going to use the binomial probability one, which there is a question on here right now.
I remember you telling me it would be like it's gonna be hard to do on this one because I'm gonna have to do it. Like,
Yeah, because you have to keep changing it.
How did you find it in that? Something?
You go-
Click functions. You're on the scientific one?
I just downloaded.
Oh, actually, no, this one you don't have to. Oh, you're in the back. All in.
Oh, okay. All right, thank you.
Go. It's the same thing on the app. Yeah. All right. Next one. Find the area under the standard normal curve between z is negative 2.99 and z is 2.72. This one's simple. They're giving you the z's. You literally have to look at the chart. Okay? But this is where those nice little bell curve things come in handy, because the picture is going to help you figure out where you're going. So remember my means in the middle. No, I'm drawing it out. I figured you could look at this for a second, because once I switch over, you're not going to be able to really read the question. So that's my curve, and they want to know the area between these two. So they're looking for this area in here. Okay. So we're going to look at our z table, find negative 2.99. And that is 0.00139 and 2.72. 0.99674. And then what are we going to do to those two? We're going to subtract. Because I want the middle. So my middle is 0.99535. I know. Couple more to go. All right, so that one, again, it's like you have to look at, notice there's quite a few problems that we're using the bell curve. There's quite a few problems that are using the bell curve. It's just a matter of figuring out what you're looking for. And that's where I think the picture really helps, because you put the information on there. It's like, okay, I'm looking for this. Now we can go start doing the process to it. So, all right. Oh, that was not what I wanted to do. Yeah. So what happens when we start to get tired. Click wrong button. All right, next one. Box contains 9 green marbles, 12 white marbles. If the first marble is chosen was a green marble, what is the probability of choosing without replacement a white marble? And you can write your answer as a fraction in this case. So remember, probability is 2 things: the number of things you have and the number of things you want. So if we've chosen a green marble, how many white marbles are left? Still 12. How many total marbles are left in the bag? 20. We had 21 marbles in the bag to start with.
Oh, okay.
I've taken one out already, so I have 20 left. So the answer is 12 over 20. I don't know if it wants you to, it requires you to reduce it. I don't really care. So 12 over 20.
What would the 20 be example?
Number of marbles left. There's 20 marbles left in the bag.
Oh, okay. Wait, I know this might be infuriating. But if there's 12 marbles plus 9, you would get the 20, right?
Correct, but I've already taken a green marble out. That's where the 20 comes from. All right, next one. 2 more to go. A researcher wishes to conduct a study of color preference of new car buyers. Suppose that 30% of the population prefers the color brown. You're asking about the probability to distribute the binomial ones. This is the binomial one. 18 buyers are randomly selected. What's the probability that exactly 8 buyers would prefer brown? So this is that formula, the NCR, and then it was P raised to the R times 1 minus P raised to the N minus R. So this is where we needed to figure out N, R, and P. So what is the number of people? The number of buyers they've selected? 18. What is the number that they want? 8. I made sure I chose the question you would only have to do once. So it's not going to say less than 8, greater than 5, things like that. It'll say exactly 1. So you only have to do this formula once and not 5 and 6 times. What's the probability? 30. You got to make sure you do it as a decimal, so it's 0.3 or 0.30. Eight. So you got your numbers down. That's my formula right there. So you're going to type in a Desmos 18 comma 8.3 raised to the 8th power. 1 minus 0.3 raised to the 18 minus 8 power. And you should get, you type it in correctly, 0.0811. Yeah, so basically, that's what I typed in the calculator. I did a few of the calculations to make my life a little easier typing it in. Like I did 1 minus 0.3, and I did 18 minus 8. But yes, you could type the entire thing right on the calculator. It would give you the right answer. Yes.
Why would there be a 1 minus 3?
It's 1 minus 0.3 because that's the,
Oh, okay.
And there's like,
I forgot the decimal.
the total of the population, or is like what you want.
yeah, this is the probability that you get exactly 8 buyers that would need brown would be about 8%. So if I'm a person selling cars, I'm probably not going to have 8 brown cars on my lot because there's only an 8% chance that I'm going to sell them all. Mm-hmm. Yes, this one is always NCR. Okay.
And that's P to the power.
Yes, P to the power of R, and then 1 minus P to the N minus R.
For the NCR, how'd you get the 18 8? So I see that in formula.
The 18 is the buyers,
Yeah.
and the 8 is the number of people that, or the randomly selected. The 8 was the one who wanted brown.
But
Oh, it's because this is how you're typing it into the calculator.
okay.
Technically, it'd be written as 18C8, but the calculator doesn't want, like, you're not typing that in. I wrote that exactly how you would type it in the calculator. Yeah, that's what the NCR means. Yeah, I got what you're saying. All right. What did I say about every question? They're all worth the exact same amount of points, right? So the next question I'm going to show you is worth the exact same amount of points as question number 4.
I'm showing everything just doesn't fit.
So let me show this question, then I'll show you that one. This question asks you which one is a normal distribution.
That is not normal.
That one's not.
That's not
There you go. That's the answer. Okay. Yes, submit my test. Did I get 100? I got one wrong. Which one did I get wrong? Oh, because I skipped it. That's why. I'm like, wait a second. I got one wrong because I skipped that one. All right. I skipped because there was 2 questions like question number 4. All right. You're using the Desmos calculator?
Yeah.
Which one, the graph or the other one? Just turn around and say it. This one? Okay. So click on function. You'll get NCR.
Yeah,
18 comma 8.
I didn't do the time, but I put it like, I kept it in the parentheses.
Oh, no. So if you're going to do that, you would have to put parentheses around this and then around this one.
Yeah. Oh, yeah. That's what I.
Oh my gosh, no more to flash up. Like, once I started reading, I was like, oh.
Oh, it's not 8. Okay, you have a couple things. You have too many extra little spaces here. Yeah,
Thank
there's
you,
a
see you
space.
Thursday.
So get rid of that.
How'd you get rid of it?
This backspace. And then this one, see if there's an, and you have 18 up there. We didn't want it. It's actually 18 minus.
Oh, yeah, no, I was trying to do that.
Yeah, you have to put it in parentheses.
That's all it's for.
18 minus. Okay.
So
Yes.
I got a question about
Sure.
just how would I find like whatever it is like -1? I kind of missed that part.
Oh, it's just look at the table. If it's greater than -1, the only answer is 0.2.
okay, greater than -1. Okay, yeah, cool.
If it was less than -1, it'd be those.
Gotcha. Okay.
That's
cool,
it.
cool, cool. Like that episode was recorded, right? It's like looking back.
Yes, I did record it.
What was that first one? The one that I missed?
Hold on one second. Let me just stop the recording.